Hi everyone. In today's session, we will learn integral calculus. To begin with, here are fundamental formulae. Please refer to the notes or you may find these formulae in any book. Okay, so next is methods of integration. There are various methods of integration by which we can reduce the given integral to one of the known standard integrals, right? So first is integration by substitution. Integration by substitution. Okay. So let us say we have let I is equal to integral fx dx. So the given integral function can be transformed into another function by changing the independent variable x to t. So now let us say we have di by dx is equal to fx. Now put x is equal to phi t so that dx by dt is equal to phi dash t, then di by dt is equal to di by dx to dx dt, which is fx and phi dash t, right? Which is f of phi t dot phi dash t. Yes. So this gives integral f of phi t dot phi dash t. Okay. Right? So, and dt. Right? Let us understand this with an example. Evaluate sin x cube x square dx. Right? So in this equation, the independent variable can be transformed into another variable, say t. So substituting x cube as t, say equation 1. Now differentiating so 3x square dx is equal to dt. Now substitute the equation value of x cube and 3x square dx is equal to dt in the given problem. So we have integral sin t dt. Okay. So this has reduced to a known standard integral. So thus the integration of this equation will be cos minus cos t plus some constant. Again putting back the value of t from this equation 1, we have minus cos x cube plus c Okay. So this means the general form of integration by substitution is to evaluate integral f of phi x phi dash x dx is equal to f of t dt, where t is equal to phi of x. Second form is integral f dash x by fx dx is equal to log of fx. Okay, so put fx is equal to t, then differentiating we get f dash x dx is equal to dt. That gives integral f dash x fx dx is equal to dt by t, which is log t, and log f of x. So right, thus the integral of a fraction whose numerator is the exact derivative of its denominator is equal to the logarithmic of its denominator, right? Let us understand this with an example. We have to evaluate 4x cube by 1 plus x raised to the power 4 dx. Okay. So let us put, if we put 1 plus x raised to the power 4 as t, then we will have 4x cube dx is equal to dt, which reduces to dt by t log t, which is nothing but log of 1 plus x raised to the power 4. Yes. So we have some important formulae based on this form. Okay. See, integral tan x dx is equal to sin x by cos x dx. So which will result in log of sec x, secant x. Similarly, we have other formulae, right? So then we can have third form, integral f of x raised to the power n f dash x dx is equal to f of x n plus 1 by n plus 1, right? So put fx is equal to t and proceed. Okay. So similarly, it can be proved integral f dash x root under f of x dx is equal to 2 root under f of x. Okay. So now the second method of integration is integration by parts. Okay. So let u and v be two functions of x, then integral u v dx is equal to u integral v dx minus integral du integral v dx. For deciding the first and the second functions, one can follow the Eilate rule for integration. Eilate rule, where Eilate stands for I is inverse trigonometric function, inverse trigonometric functions, sine inverse x, cos inverse x, etc. L for logarithmic function, log x, ln x, etc. A for algebraic function, example x cube plus x power 4 plus 2 x square, etc. T for trigonometric function, sin x, cos x, etc. And E for exponential function. Okay, such as, okay, so right, so we have also one more general rule of integration by parts, which states that if u and v be two functions of x, okay, so u v dx, integral u into v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus and so on. Okay, so where dashes denotes differentiation, order of differentiation, and suffixes denotes integrations, order of integration. Okay, so in other words, integral of the product of two functions is equal to first function into integration of second minus go on differentiating first, integrating second, okay, and so on, and obviously signs alternately positive and negative, positive, negative, positive, negative. Okay, I repeat. Okay, integral of product of two functions u into v is first function into integral of second minus differentiate first, then integrate second, again differentiate this, integrate this, again differentiate this and integrate this, which is v4, and so on, alternately positive, positive, negative, positive, negative, right? Okay, this is quite useful in Fourier series, solving Fourier series problems. Okay, finding the series. Okay, now Next is integration using trigonometric identities. Third, okay, we have some formulae based on this integration by parts, such as, I think I have, yes, this is the formulae based on integration by parts. Okay, this and this, right? Let us go back. So third is integration using trigonometric identities. Okay. So if the integrand involves any kind of trigonometric function, then we use integration by integration using trigonometric identities to simplify the function. Okay, so let us see few identities, trigonometric identities. So we can replace sin square x by 1 minus cos 2x by 2. Similarly, cos square x by 1 plus cos 2x by 2, sin cube x as 3 sin x minus sin 3x by 4. Also, cos cube x is equal to 3 cos x plus cos 3x by 4. Okay. So all these identities simplify integrand that can be easily found out. Here are some formulae. Okay, you can easily prove each of them. So next is integration by partial fractions. So these are the methods how to simplify the integration. I have already discussed this, and there are few more. Okay, you can check this. You can refer to my handwritten notes. Okay, the last one is integration by partial fraction. So if you have the form such as px plus q by x minus a and x minus b, okay, so you can simplify this by finding a and b, capital A and capital B, such that this equals this, right? Okay. So for example, let us have find x integral x by x minus 1, x minus 2 and x minus 3 dx. So let us decompose this into sum of proper fraction. Okay, so a by x minus 1 plus b by x minus 2 plus c by x minus 3 dx. Let's say this is equal to this. So we have to find a, b and c. Let us find a, b and c coefficients. So to find a, multiply x minus 1 and put x is equal to 1 in the original given fraction. X minus 2 and x minus 3. X minus 1 gets cancelled. So this, and put x is equal to 1. So 1 by minus 1 and minus 2. So plus 2. So 1 by 2. A is equal to plus 1 by 2. So for b, multiply this fraction by x minus 2 and then put x is equal to 2. So x minus 2 okay, x minus 1, x minus 2, x minus 3, put x is equal to 2. So 2 by 1 and into minus 1, which is minus 2, right? Similarly, to find c, let us multiply this by x minus 3 and then put x is equal to 3. So x minus 3, x by x minus 1, x minus 2 and x minus 3, and put x is equal to 3. So 3 by 2 into 1, which is 3 by 2. So this is b and this is c, right? So now let us put the values of a, b and c here. So we have to find 1 by 2 x minus 1 minus 2 x minus 2 plus 3 by 2 x minus 3 dx, right? Now this is integral of this is half log of x minus 1, then minus 2 log of x minus 2 plus 3 by 2 log x minus 3 plus constant. Okay. Let us see one more example. Find integral 1 by x square minus a square, okay, dx. So this can be written as 1 by x minus a and x plus a. Again, using partial fraction method, we can have 1 by 2a, 1 by x minus a minus of 1 by x plus a, right? So again, we can finally write this as 1 by 2a integral dx by x minus a minus integral dx by x plus a, which is equal to 1 by 2a log x minus a minus log x plus a, which is again equal to 1 by 2a log x minus a by x plus a. So this is how we proceed using integration by partial fraction. Here is the summary of some important results. Try to derive these integrals using methods of integration discussed so far. For example, in this case, put x is equal to a sine theta to get dx is equal to a cos theta d theta, and then proceed. Try to derive these on your own and let me know if you face any difficulty. Okay, now let us go back. So next is definite integrals. Definite integrals. Right? So there are few properties, fundamental properties of definite integrals. First one is integral a b fx dx is equal to, if you interchange the limit, it will change the sign of integral. Okay, so interchanging the limits of a definite integral does not change the absolute value but change the sign of integral, right? Next is a and b fx dx. So a c fx dx plus c b fx dx. This property also holds true even if the point C is exterior to the interval a comma b, right? And in place of one additional point C, we can take several points. Say fx dx equal to a c1 fx dx plus c1 c2 fx dx plus c2 c3 fx dx, so on, cn b fx dx, right? So third property is fx dx is a b f of a plus b minus x dx. Okay, so if you have one limit as 0, say 0 to a f of x dx will be equal to 0 to a f of a minus x dx. Okay, next, integral minus a plus a fx dx is equal to 0 if fx is odd and okay, and 2 0 to a 0 to a f of x dx if even, right? Next, three, four. So fifth property is 0 to a fx dx is equal to 2 0 to a fx dx if f of 2a minus x is equal to f of x, and 0 to 2a fx dx is equal to 0 if f of 2a minus x is equal to minus of fx, right? Next is reduction formulae. Zero to pi by 2 sine nx is equal to 0 to pi by 2 cos nx dx is equal to n minus 1, n minus 3, n minus 5 to so on by n into n minus 2, n minus 4 into pi by 2 only if the index n is even, right? Okay. So this is called Wally's formula, known as Wally's formula, right? Okay, and next is deduction formulae for integral sine mx cos nx dx and 0 to pi by 2. So this is equal to m minus 1, m minus 3 into n minus 1, n minus 3 and so on. In the denominator, m plus n minus 2, m plus n minus 4 and so on. Okay, into pi by 2 only if both m and n are even, right? Only if both m and n even, right? Let me discuss gamma function with you. So gamma function is denoted by gamma n and this is an improper integral 0 to infinity e raised to the power minus t and t n minus 1 dt. Okay, so this is an improper integral which is dependent on the parameter n, right? So standard results of gamma functions are gamma half is equal to root pi. Second, gamma n is equal to n minus 1 factorial. Third, gamma n plus 1 is equal to n gamma n gamma n if n is fraction, and this is equal to n factorial if n is positive integer. Okay. Next is gamma minus half is equal to minus 2 root pi. Okay. So, and using gamma function, okay, there is one more function, beta function. Beta function has two parameters m and n, denoted as bmn, is defined as 0 to 1 x m minus 1 1 minus x n minus 1 dx, okay, where both m and n are greater than 0. So gamma function, beta function is equal to gamma m gamma n by gamma m plus n, right? Also, using Wall's formula, you can derive sin mx cos nx dx is equal to gamma m plus 1 by 2 gamma n plus 1 by 2 whole divided by 2 gamma m plus n plus 2 by 2, right? Next is Lebanese Rule. So consider a function of two variables x and y, say z. Now let us consider the integral of z with respect to x from a to b f of xy dx. So for this integration, the variable is only x and not y. Okay. So y is constant for the integration process. So therefore, after we have evaluated the definite integral and put in the integration limits, y will still remain in the expression of this I. Okay, that means I is a function of y. Yes. So variable is only x and not y. Y is a constant. For integration process. So after evaluating definite integral, y will still remain, and that means I is a function of y. Clear? So say Iy is equal to a b f of xy dx. Yes. So now Lebanese Rule say d by dy means I dash y is equal to integral a to b f of x comma y dx is equal to a to b partial derivative of f of xy with respect to y and dx. Okay, so this stands for the partial derivative of f of xy with respect to y, that is the derivative of f of xy with respect to y treating as x as a constant. Next is Lebanese rule for variable limits of integration. Okay, so Lebanese rule for variable limits of integration states that for an integral of the form ax bx f of xt dt and derivative of this integral can be expressed as f of x bx to d by dx bx minus f of x ax d by dx ax plus ax bx, then partial derivative of f of x comma t with respect to x dt. Okay, yes, where partial derivative indicates that the integral only the variation of f of x comma t with x is considered in taking the derivative. Okay. And in the special case what we discussed earlier, this can be derived from this when ax and bx, ax is constant and bx is constant with values that do not depend on x, then this simplifies to this. Okay. Okay, next is applications of definite integral. Applications of definite integral. Okay. So first is area of curve. Okay, so in Cartesian form, formula is x1, x2, y1 and y2 dy dx, and in polar form, area bounded by the curve r is equal to f theta and the radii vector theta is equal to alpha and theta is equal to beta is half alpha beta r square d theta. So through graph we can show okay. So this is radius vector theta is equal to beta and this is radius vector theta is equal to alpha and area bounded is okay, and this is the curve f theta. Okay. Next is length of the curve or arc length. Okay. So we have for Cartesian form, for y is equal to fx, between the points where x is equal to a and x is equal to b is given by integral a to b root under 1 plus dy by dx whole square dx. For x is equal to f of y, between y is equal to a and y is equal to b is integral a to b root under 1 plus dx dy whole square dy. Okay, for curve x is equal to f of t and y is equal to f of t between the points where t is equal to a and t is equal to b is integral a to b root under dx by dt whole square plus dy by dt whole square and dt, right? And in polar form, r is equal to f of theta. We have integral alpha to beta root under r square plus dr by d theta whole square d theta, right? Next is volume of revolution. Volume revolved by x-axis. Revolved by x-axis is given by a to b integral pi y square dx. Okay. Similarly, volume revolved by y-axis is given as integral a to b pi x square dy, right? Next is multiple integral. Right? First one is double integral. Which is expressed as x1, x2, y1, y2, f of xy dx dy. So when y1 and y2 are functions of x and x1 and x2 are constants, then f of xy is first integrated with respect to y. Let me show you. Okay, keeping x fixed between limits y1, y2, and then the resulting expression is integrated with respect to x within the limit x1 and x2. Okay. So similarly, say this is I1, and when x1, x2 are functions of y and y1, y2 are constant, then fxy is first integrated with respect to x, okay, keeping y as fixed within the limit x1, x2, and then the resulting expression is integrated with respect to y between the limits y1 and y2, right? Say this is I2. So in the first case, we integrated along the vertical strip, and in the second case, we are integrating along the horizontal strip. Vertical strip and horizontal strip. So both, obviously I1 is equal to I2, okay, And for constant limits, it hardly matters whether we first integrate with respect to x or with respect to y, right? So if limits are constant, then you can solve either way. Okay, you can take first with respect to x or first integrate with respect to y or vice versa, right? So next to this is change of order of integration. Change of order of integration. Okay. So this facilitates, change of order of integration facilitates the evaluation of a double integral. Okay. Let me take one example that will make the idea clear. Let us integrate 0 to 1 x square 2 minus x xy dx and dy. So change the order of integration. Change the order of integration and evaluate. Right? So here the integration is first with respect to y because x is constant. Okay, that means along a vertical strip. So let us draw first the region of integration. See, this is x axis, this is y axis. Okay, we have to draw y is equal to x square. Then y is equal to 2 minus x means y plus x is equal to 2. So, okay, so y is equal to x square is a parabola. Y is equal to x square. Then x plus y is equal to 2 is, if you put x is equal to 0, then y is equal to 2. And if you put y is equal to 0, then x is equal to 2. This means that this point 2 comma 0 and 0 comma 2. Join them. So you have x plus y is equal to 2. Right? Now we have vertical strip. Okay. See, this extends from the point on parabola y is equal to x square to the point on the line y is equal to 2 minus x. Okay. That means we have vertical strip as okay, this is a vertical strip, and in order to change the order of integration, we first integrate with respect to x along the horizontal strip. Okay, so we have to find the horizontal strip. Right? Okay, let us name the points O, A and B. Okay. So now Let us find this point of intersection first. So which is, by solving these two equations you will get 1 comma 1 as the intersection point. So if you notice that below this point, okay, below this point, the lower limit, let us draw the horizontal strip again. So if this is P and this is Q, okay, so notice that P lies on this y-axis and Q lies on y is equal to x square, okay, and above this line, P lies on y-axis and Q lies on y plus x is equal to 2 on this line. So this requires splitting up of this region into two parts, okay, for this and for this. For this. So in this region y is varying from 0 to 1, 0 to 1, and for this region y is varying from 1 to 2, okay. So let us split up the region into two parts. Then contribution of integration from this region will be I1 is equal to zero to 1 dy, 0 to, okay, x is varying from 0 here, 0, x is 0 here, and here x is equal to root under y. So root under y xy dx, okay, and from this region, from B, this region, okay, we have I2 as, so y is varying from 1 to 2 and x is varying from 0, x is 0 here, 2, x is 2 minus y, x lies on this line, so x is equal to 2 minus y, so 2 minus y xy dx, okay. So that means total contribution is I1 plus I2, which is integrate 0 to 1 x square 2 minus x xy dx dy, okay, zero to 1, 0 to root y xy dx dy, right, plus integral 1 to 2 0 to 2 minus y, xy, dx and dy. Okay. Now solve this. So here this will be, so integrating with respect to x, we have x square by 2, put y as constant and then put x is equal to 0 to root y, okay, and then integrate 0 to 1, and for this we have 1 to 2. Here again put y as constant, so x square by 2 y, 0 to 2 minus 1, right, and dy. Plus 2 minus y, right, and dy. Okay, now put x square is equal to root y, that is y square, y, okay, y into y square by 2, let us take 1 by 2 outside, and 0 to 1 dy plus 1 to 2, and let us take half outside, then if you put 2 minus y, then y into 2 minus y square dy. Okay, again if you solve this, you will get 1 by 6 plus 5 by 24, which is 3 by 8. Okay, so now for double integral in polar coordinates, let us understand this with an example. Calculate double integral r cube dr d theta over the area included between the circles r is equal to 2 sin theta and r is equal to 4 sin theta. Okay, so given we have two circles, so let us draw first. So we have two circles, 1 and 2. Okay, so one circle is r is equal to 2 sin theta and one is r is equal to 4 sin theta. So we need to find this area. Okay, so we have our limits, r is equal to 2 sin theta and r is equal to 4 sin theta, and theta varies from 0 to pi, So thus the required integral is 0 to pi integral 2 sin theta, 4 sin theta and r cube dr d theta, right? So which is equal to 0 to pi r raised to the power 4, 2 sin theta and 4 sin theta, then d theta. Okay, so which is 60 0 to pi sine 4 theta d theta. Okay. So now using property, you can write 60 into 2, 0 pi by 2 sine 4 theta d theta. Okay. Because we can write this pi as pi by 2 into 2. Okay. So this way you can take 2 out. So now using reduction formula, using Wally's theorem formula, so we have n as even, n is equal to 4, which is even. So for n is equal to 4, here n is equal to 4, so 0 to pi by 2 sine 4 theta d theta will be equal to n minus 1, that is 4 minus 1 into 4 minus 3. Okay, and in the denominator it is 4 into 4 minus 2, 4 minus 4, which is 0, so avoid that. And then since this 4 is even, we have to multiply by pi by 2, so which is equal to 3 by 8 into pi by 2. So the required integral I will be equal to 120 into 3 by 8 or 3 by 16 pi. Okay, so this is the required answer. Okay, so let us solve one more example. Find area between parabola y square is equal to 4ax and x square is equal to 4ay. Okay, let us draw first the curve. So y square is equal to 4ax is this curve and x square is equal to 4ay is this curve. So this is x square is equal to okay, this is x square is equal to 4ay and this curve is y square is equal to 4ax. We need to find out this area. Okay, and these parabolas intersect at 0, 0 and at, if you solve this two equation x square is equal to 4ay and y square is equal to 4ax, you will get the intersection point as 4a comma 4a, right? Then the shaded area between these two parabolas, so x is constant, so x is constant, so this is a vertical strip, right? Say P and Q. So if you move this slider PQ, okay, from left to right, so x is varying from 0 to 4a, okay, x varies from 0 to 4a, and for y, so lower limit lies on x square is equal to 4ay, okay, and upper limit lies on y square is equal to 4ax. So y varies from x square by 4a, okay, lower limit, y is equal to x square by 4a, to root under ax, to root under ax, okay. So now we can write the required area as double integral 0 to 4a x square by 4a to root under ax dy dx. Yes, and so this is 2 root under ax minus x square by 4a dx 0 to 4a, and if you solve this, so you will get 2 root a into 2 by 3 x power 3 by 2 minus 1 by 4a into x cube by 3 0 to 4a, okay. So now this reduces to 32 by 2 a square, that is 16 a square minus 16a square by 3, 16a square by 3. So this will be the required area between the parabolas y square is equal to 4ax and x square is equal to 4ay, right? So next is triple integrals. So you can integrate first f of x, y, z. F is a function of x, y and z. So integrate with respect to z, dz, z1 x comma y, z2 x comma y. Okay, now you can then integrate so first you integrate fxyz with respect to z between the limit z1 and z2 keeping x and y fixed. Then the resulting expression is integrated with respect to y between the limits y1 and y2 keeping x as constant. Then the result obtained is finally integrated with respect to x from x1 to x2, right? So integration is carried out from the innermost to the outermost bracket. And the order of integration may be different for different types of limit. For example, let us consider a simple example of triple integral x plus y plus z integrate dx, dy and dz. So x minus z, so x plus z, and 0 to z and minus 1 to y. So obviously this is limits of y, and this is limit of x, and this is limit of z. So first you have to integrate with respect to y, keeping x and z constant. So then we will have zero to z and minus 1 to 1. So xy plus y square plus by 2 plus yz, x minus z, 2x plus z, dx dz. Okay. Now integrate with respect to x. So you will get minus 1 to 1 x square z by 2 plus z square x plus x square by 2z dz. Now finally integrate with respect to z, okay, from minus 1 to plus 1. So you will get 4 minus 1 to plus 1 z square by 2 plus z cube plus, this was 0 to z, and z cube by 2 dz. So which is equal to 4 z power 4 by 4 z power 4 by 4 minus 1 to 1 into 4, so which is equal to 0. Okay, so this way you can calculate multiple integral. So we have finished integral calculus and application of integration, definite integral. So we have covered area, length and volume. Okay, so in the next lecture we will solve selected problems on integral calculus from previous year examinations. Okay, so let's wind up here. We will meet in the next lecture. Till then, keep preparing. Thank you.